Maybe we should do something to help your understanding here. Let's draw a graph. Now, this is what I do in the third grade classes. So the ordinate, the y-axis, we're going to call what?
Fluorescence.
Fluorescence, but
Intensity of fluorescence?
it is fluorescence, you're right. But what would you say to third graders?
Amount of color.
How about glow? Like a glow stick, okay. And what are we going to have along the x-axis?
Squirts.
Squirts, okay, squirts of riboflavin. And so let's just say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for the this one, which is the eggs that are clear, colorless, what did that graph look like? What would you say? Okay, Camus says it went like that, right? And the other one did what? So Camus, okay, so it goes like this, and then all of a sudden it does that, right? So this would be, I'm going to call these normal egg white. And this would be, I'm going to call these mutant X white. So we're doing a titration here. So what are we titrating? What are we titrating? Hypotheses. You don't have to know the right answer. We're not asking about right answers, wrong answers. We're asking for curiosity and postulates and hypotheses about what might be going on here. Huh?
The concentration of whatever stops the fluorescence.
The concentration of whatever stops the fluorescence, okay? So that's a good hypothesis. So there's something in this egg that quenches the fluorescence that's missing in here. So what you're saying is there's something here in addition to the riboflavin that isn't here. So it's not only that there's riboflavin here, there's something else here. Two things missing here. So that's something you're defining as something that quenches the fluorescence. Now, I've given you a hint here. So what do you think that something might be?
The nutrient that it's missing, or the thing that it's missing?
Well, now the nutrient they're missing we know is riboflavin.
Right.
So it has to be something other than riboflavin. So what might it be? So when you think of a mutation, where do mutations happen?
DNA.
In the DNA. And DNA codes for what?
Proteins.
Proteins. What do you think might be missing here?
Protein.
A protein. Okay, so a protein is missing in this one. And what do you think that protein does?
Is it an enzyme?
Is it an enzyme? Could be an enzyme, I suppose, but in this case it's not. But it has some properties of enzymes in that it interacts with a small molecule.
It reacts with
It
riboflavin.
reacts with riboflavin, and it has the very creative name, riboflavin binding protein. Okay, so these chickens, these eggs come from chickens that are incapable of producing a functional riboflavin binding protein because they have a mutation. And the chickens that lay these eggs have a functional gene that produces a riboflavin binding protein. So in the absence of that protein, these chickens lay eggs that lack riboflavin. So the function of that protein is to do what? Bind to riboflavin, but not only bind, and this is more on a biological level. I mean, that's what it does biochemically, but what does it do in binding to riboflavin?
Stores it.
Well, it's not only stores it, but that riboflavin has to come from the hen, right? It has to be deposited in there. So it is responsible for putting riboflavin into the egg. So when I started off, I talked about how all the nutrients are necessary for the development of a chicken egg had to be prepackaged there. So when you think about it, every single nutrient that you would need and a chicken embryo would need has to have some biochemical process for getting into the egg. So in this case, there's a specific protein that binds to the vitamin riboflavin and deposits it in the egg. And that also goes into the egg yolk. And that is true for several other of the nutrients that you would think of. Each one of them has a biochemical system that's involved in transport. So that is the end of my formal show. Are there any questions?